Okay, so for this problem, we have to solve for y. So usually for something like this, we would just factor it out and then see how the roots, if the roots are equal to each other, different, or if they're complex. But for this one, it's going to be something interesting. So if we divide everything by x squared to get this being times by 1, and we set m to be dy over dx, we get the following. Okay, and notice how this really isn't factorable. So because we ran into this kind of problem, so it's not really factorable because how are we supposed to work with these x's? If they were constants, then we could have just used a quadratic formula to solve for it. But I don't really know how to work with these x values. So what we're going to do is get rid of all of this, and we're going to use Cauchy's and Euler's equation, where we set y to be equal to we set y to be equal to x to the power of m. The derivative of that will be m times x to the power of m minus 1, and the second derivative will be m times m minus 1 times x to the power of m minus 2. So we plug this into here, this into here, and this into here. So we should get the following. Okay, and recall this can be rewritten as the following, and so is this one. And look at this. This and this cancels each other out, and this cancels each other out. So we get the following. And now we see all the xm's. We can cancel all of those out by dividing the whole thing by xm. So now we have now our equation looks much more smaller. So this is just m squared minus m minus 2m minus 4. So that's just m squared minus 3m minus 4 equals 0. So factor all of this out. So this will be plus 1, this will be minus 4. So m1 will be minus 1, and m2 will be 4. Okay, different roots. So the problem is a lot of people are going to make the mistake and write y to be equal to c1 times e to the power of m1x plus c2 to the power of em2x. So c1 e to the power of m1x plus c2 times e to the power of m2x. But this is not the case when you're using Cauchy and Euler's equation. So when you're using this equation, well, you have to actually write it is like this. You write it like c1 x to the power of m1 plus c2 x to the power of m2, with this being minus 1 and this being 4. And that's your final answer.